So in this next diagram, next problem, we're going to take a look at how to write an orbital diagram for chlorine. So from the periodic table, there is, under chlorine, there's a configuration that reads 2-8-7. And again, ignore this blue line. I can't do anything about that. But 2-8-7 means there are 2 electrons in the first energy level. Here's the first energy level. How do I know? Because it's got a 1. Okay, this is the S sublevel. The box represents the 1 orbital that is in the S sublevel. So I'm going to take those 2 electrons and show them as arrows. I'm going to draw an up arrow and I'm going to draw a down arrow. Okay, so right there are the 2 electrons that are found in the first principal energy level. Now there are 8 electrons in the second principal energy level. The second principal energy level is anything with a 2 in front of it. So the second principal energy level has an S sublevel and a P sublevel. In the S sublevel, there is only ever 1 orbital, so I'm going to show that with 1 box. In the P sublevel, there are 3 orbitals, so I'm going to show that as 3 boxes. So each one of these orbitals is an electron cloud where it can hold as many as 2 electrons, but no more than 2 electrons. So let's place those 8 electrons. Those first 2 electrons have to go into the lower energy level available, so that would be the 2s. So that is 2 electrons of those 8. So now I have 6 more to place. The next higher energy level is the 2p sublevel. So I'm going to, the correct order to fill these orbitals when there's more than 1 orbital in a sublevel is to put 1 electron into each orbital, and then you can start filling them up. So there I'm going to put the second electron in that first box, here, here. So that what we've got now is 1, 2, 3 electrons, 4, 5, 6 electrons in the 2p. Okay, so really if I was to draw this as an electron configuration, this part right here represents the 1s2, this represents the 2s2, and this represents the 2p6. Okay, again, apologize for the bad writing. I'm trying to write with my mouse pad. I'm not very good at that. So there's the 8 electrons that I've just placed in the second principal energy level. All right, and so we're getting further away from the nucleus now, and further away from the nucleus means that the electrons will be at a higher energy level. So there are 7 electrons to place in the third energy level, first energy level, second energy level, third energy level. So the third energy level is here. There's a 3s, there's a 3p, and a 3d, but notice the 4s is lower than the 3d. All right, so if you follow these in this direction, this is increasing energy. And so if you have an orbital diagram, and one will be given to you on the test, that this will tell you the order that you fill up the orbitals. You just start at the bottom and you work your way up. So 7 electrons into the third energy level. We're going to start at the lowest sublevel of the third energy level. That's the 3s. So now I've got 3s2. Right? So there's 2 of the 7 electrons I need to place in the third energy level. So there's 5 more to place. I'm going to put them 1, 2, 3, 4, 5, and then that's done. So there's our 7 total electrons in the third energy level. Okay, so that would be a 3p5. All right, let's take a look at this last question. An incorrect orbital diagram for the ground state oxygen is shown below. Circle the error in the diagram and draw the correct diagram. All right, so what is wrong in this diagram? 2 electrons here, 1 up, 1 down, so that means the electrons are spinning in opposite directions, which this part is okay. The 2s, there's 1 arrow up, 1 arrow down, there's 2 electrons having opposite spins. This part's okay. Now over here in the 2p, where there are multiple orbitals, you should not be filling up these 2 orbitals before this one isn't even filled. So right here, it is this electron right here that is incorrectly placed. So if you were to correct it, you would have these, we said with these electrons were okay, but these 1, 2, 3, 4 electrons in the 2p should be placed 1, 2, 3, 4. Okay, so that's how you do those types of questions. So let's take a look at the multiple choice part of this review. The question is, how many different types of orbitals are in the third principal energy level? So the key word here is types of orbitals. Okay, types of orbitals are basically, we're asking you about sublevels. right? So the types of orbitals, there's an S-shaped sublevel or orbital, there's a P-shaped orbital, and there's a D-shaped orbital, and then there's an F-shape, right? We sort of talked about these shapes in the previous video lecture. S is the spherical shaped one. P is more of a propeller, peanut. Sometimes it's referred to as a peanut shaped or even a dumbbell shape. D is like a four-leaf clover, and F is more flower-like. So each one of these sublevels contain orbitals, but the orbitals, what we're talking about here, types of orbitals, what we're really talking about are sublevels. So the question is, how many different sublevels are there in the third principal energy level? Well, let's quick little roundabout review. First energy level, there is only one sublevel. It is S. The second principal energy level, there are two sublevels, S and P. In the third energy level, we have three sublevels. We have an S, we have a P, and we have a D. That's supposed to be a D. Okay, so there are different types of orbitals, three different types of orbitals in the third principal energy level. Next question. What is the maximum number of p orbitals in a principal energy level? Okay, so p orbitals, when we talk about orbitals, we're talking about boxes. So in an s sublevel, there will be one box. In a p sublevel, there will be three boxes or three orbitals. And in a d sublevel, there will be five orbitals or boxes. And then, of course, the f will have 7. So the maximum number of p orbitals in a principal energy level will be 3. Okay, in any p sublevels, whether it's 2p or 3p or 4p, there will always be 3 orbitals, which we often just see as boxes. What is the maximum number of electrons in the third principal energy level? Well, we already said that there's in the third principal energy level, you can have an S, you can have a P, and you can have a D. The maximum number of electrons you can have in an S is 2 electrons. The maximum number of electrons you can have in any P sublevel is 6 electrons. And the maximum number of electrons you can have in any D sublevel is 10 electrons. So 10 plus 6 plus 2 is 18. So you can have 18 electrons maximum in the third principal energy level. Right? So the third principal energy level includes 3s with 2 electrons max, and 3p with 6 electrons max, and 3d with 10 electrons max. So the entire third principal energy level could contain 18 electrons maximum. Next question. The letter S in the symbol 2s2 indicates what? Well, it indicates the sublevel, right? That's the sublevel. But we also said that the sublevel also tells you what shape the orbital is, right? Remember, the S sublevel is the spherical shape. The P sublevel is the peanut or the propeller shaped, right? So S is the sublevel S has a very distinctive orbital shape. Okay. S is spherical, P is peanut, D is four-leaf clover, and F is a flower. Number 15, or the next question here, I think your numbers might be a little different, but what type of atomic orbitals are in the second principal energy level? So what types of orbitals? Types of orbitals, again, are sublevels, right? So what sublevels? And I'm sorry, that's writing, okay, I just cannot write very well with my mouse pad, right? So types of atomic orbitals are sublevels. Actual orbitals are the boxes or the electron clouds where the electrons actually exist. So the types of atomic orbitals that are in the second principal energy level is only S and P. The second principal energy level has only S and P orbitals only. Number 16, or the next question, what is the number of electrons in the highest principal energy level of a carbon atom? Well, if you look up, let's see, if you look up carbon, let's see if we can take a look at carbons. Let's take a look at carbon. Okay, carbon is 2-4, looking right here at this electron configuration, right? So 2-4. Okay, that's a 2. What is the number of electrons in the highest principal energy level of a carbon atom? The highest principal energy level is this number, Okay, or it's the second number, so this is the second principal energy level, but the question is asking for how many electrons are in the highest energy level. So the last number is the highest principal energy level where electrons can be, and the actual number is how many electrons there actually are. So 4. Okay, so we answered this question a lot simpler than this explanation. The electron configuration of carbon is 1s2, 2s2, 2p2. This is a bit more information than what is given on your periodic table. Our answer was a little bit more straightforward, so let's stick with that answer. Okay, let's take a look at the next question. Which one of the following electron configurations can exist? All right, so when we say that it can exist, we're talking about ground state, which means that the electrons have to fill in the order that they're supposed to fill from the lowest energy to the highest energy. There shouldn't be any skipping. So if we take a look here, 1s2, 2s2, 2p2. Well, right here, 2p2, there's a p sublevel can hold up to 6. We shouldn't be putting electrons in the next higher energy level until this one has 6. So right here, that one's flawed. So it can't be A. Let's look at B. 1s2, 2s2, 3s2. Wait a minute. Where's the 2p? Where's the 2p? It's not there. Okay, so we shouldn't be putting electrons into the third energy level if we haven't entirely filled the second energy level. So that's not a good choice. C. 1s2, 2s2, 2p10. Hey, wait a minute. There can't be 10 electrons in a p sublevel. A p sublevel can only hold up to 6 electrons. So this is no good. It must be D. Let's just verify. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Definitely, this is the one that makes the most sense. Okay, so let's take a look at the next question. All right, so if 3 electrons are available to fill 3 empty 2p atomic orbitals, how will the electrons be distributed in the 3 orbitals? All right, so this is where if you have multiple orbitals within a sublevel, you have to put 1 electron into each orbital before you can start doubling up. So this is the only one that makes sense. You can only put those 3 electrons, 1 in each orbital, before you can move on. So choice C. Okay, and it's all about stability. Electrons won't pair up in the p, d, or f orbitals until there is 1 electron in each of the orbitals first. Okay. Next question, the maximum number of electrons that can fill a single 4f orbital. Okay, so the key word here that I want you to catch is a single 4f orbital. So granted, an f sublevel will have a total of 7 boxes, 7 orbitals, but we're talking about a single orbital. Any single orbital, doesn't matter where it is in the atom, can only hold 2 electrons. Okay, so watch out for that wording. And I believe this is the last question. Which is the electron configuration of a beryllium atom? Well, let's take a look here. If we look up beryllium on the periodic table, let's see if I can get this. Oh, I'm going to need my arrow. Beryllium is going to be over here. I can move this. Beryllium is 2-2. 2-2, that's a total of 4 electrons. This first choice, 1 electron. Choice B, 2 electrons. Choice C, 3 electrons. Choice D, 4 electrons. It has to be D. That's the only one that has 4 electrons. All right, that's it for going over the quantum mechanical model review sheet. Hope this helped, and we'll see you in the classroom.